It's something we do every single day now. You drop your phone on a charging pad, and it just powers up. It feels like magic, right? No more fumbling around for cables in the dark. But how on earth does that electricity actually jump through the air? Well, let's break it down.
So is it magic? Some kind of futuristic wizardry that we've just accepted? Nope. The answer is actually way, way cooler. It's not magic at all. It's a principle of physics that's been hiding in plain sight for over 100 years. And to really get it, you don't need a PhD in physics. All you need is a really simple analogy that perfectly explains this invisible connection. And it all comes down to two tuning forks.
Okay, that's the fancy technical term, but the tuning fork idea really demystifies the whole thing. Just imagine you have two identical tuning forks. You strike one and it starts vibrating, making that classic humming sound. Now get this. Across the room, the second tuning fork, which is tuned to the exact same frequency, starts humming all by itself. No one touched it. That's it. That's the heart of wireless charging. One object sends out energy, and another one, perfectly tuned to it, picks it up.
So let's swap out those tuning forks for our charging pad and our phone. We're going to trace the path of that energy, step by step, all the way from the wall outlet, through the air, and right into your phone's battery.
The whole thing happens in 5 key steps. It's pretty straightforward, really. We start with the transmitter, create a magnetic field, the receiver in your phone picks it up, that creates a current, and then we convert it into usable power. Let's walk through each one. First up, the charging pad itself. That's our transmitter. When you plug it in, electricity from your wall, that's alternating current, or AC, starts flowing through a tightly wound copper coil inside. And that word alternating is super important. It means the electricity is constantly flipping its direction, back and forth, really, really fast. So what does that rapid back and forth current do? It generates an energy field, an oscillating magnetic field, right around the pad. Think of it like a small, invisible bubble of potential power. It's not just shooting energy out into the room, it's a very controlled, localized field. And now for our second tuning fork, your phone. Hidden inside the back of your phone is another, smaller copper coil. This is our receiver, and it's specifically designed to resonate or vibrate at the exact same frequency as the field coming from the charging pad. And here's where the magic really happens. When you place your phone on the pad, that magnetic field washes over the receiver coil. Through a process called induction, it gets the electrons inside the phone's coil excited and moving. And moving electrons, well, that's an electrical current. It's literally created out of thin air. Okay, almost done. The current that's created in the phone is AC, just like in the wall. But your phone's battery can't use that. It needs a smooth, one-way street of power called direct current, or DC. So a tiny little chip inside your phone acts like a translator. It takes that AC power and converts it into the DC power the battery can actually store. And just like that, you're charging.
So this tech is obviously super cool, but it's about so much more than just getting rid of a cable. It is fundamentally changing how our devices are designed and how we interact with them.
The impact this is having is huge. For one, we have a universal standard called Qi. That's pronounced Qi. It means you can use pretty much any charging pad with any phone, which is amazing. It also lets companies finally get rid of the charging port, which is a major point of failure. This leads to more durable, actually waterproof phones. And you're already seeing this technology being built into everything: your car, tables at the coffee shop, even furniture. All right, so whenever there's cool new tech, there are always some myths and a little bit of mystery. So let's quickly bust a really common myth and then give a shout out to the genius who thought of all of this in the first place.
You've probably heard this one. People worry that these pads are just blasting dangerous energy all over the place, like a leaky microwave. The reality? Not even close. The magnetic field is incredibly weak, and it's totally localized. It's the safe, non-ionizing kind, and it barely extends beyond the surface of the pad itself.
Just how small is that field? Well, for your standard Qi charger, the max effective range is only about 40 millimeters. That's less than 2 inches. If your phone isn't right on top of it, the whole energy transfer just stops. It's built from the ground up to be efficient and, more importantly, completely safe.
Now here's the really wild part. This is not a 21st century idea. The legendary inventor Nikola Tesla was actually demonstrating wireless power transfer way back in the 1890s. He had this grand vision of beaming electricity across the entire planet. It took more than a century, but that dream, in a small way, is now a reality on all of our nightstands.
So, where's all this heading? We've gone through the science, we've seen why it matters. Now let's kind of put it all together and take a quick look at what's just around the corner. So, what are the big takeaways here? First, it's not magic, it's just a really clever use of magnetism called resonant inductive coupling. Second, because of the Qi standard, it's universal and super easy for all of us to use. And third, it is absolutely safe, and it's the key to making better, more durable, fully sealed devices in the future.
And that kind of leads us to one last big question. Now that we can charge our phones wirelessly and transfer all our data wirelessly with things like Bluetooth and Wi-Fi, you really have to ask yourself, what is the last remaining reason to even have a physical port on our phones? That completely portless future? It might be a lot closer than you think.